Hey guys, it's Proflexin here, and today we're going to be doing some logarithms. But before we get started, I just want to say that this is going to be a two-part video. And so in the first part, we're going to be looking at logarithms and just some simple rules. And the next part, we're going to be looking at some more logarithmic laws and further examples of it as well. So let's get started. What's a logarithm? So let's start off with an example. So we will write that a to the power of b is equal to c. Now this is exactly the same as us asking what power of a can we raise by to get our answer c. And to this, we can write this as log base a of c, which would be equal to our power b. And now if we show this in terms of numbers, we can say that, for example, 5 cubed is equal to 125. Then we can say that the log of base 5 of 125 is equal to 3, because 3 is our power to get 5 cubed to equal it to 125. Now let's have a look at some rules. And the first rule we're going to look at is that a logarithm of a negative number or a 0 is not a real number. And this makes sense because when we're dealing with numbers which have indices, we will always get a number which is greater than 0 or a positive number. So that'll be the first rule. Now moving on to our second, we will say that the logarithm of base 10, and this means that it will be 10 to the power something, is written as log x. And this log you'll find on your calculators. And we're going to look at a logarithm of base e. And e you will look at, which is this number I'm writing down, but you will see this in exponential functions or in models like decays. But a logarithm of base e is written as ln x, or ln x as some people like to call it, but I prefer calling it ln x. Now, we will get to a last rule, and this rule we can write in two different ways, but they both mean the exact same thing. So the first way to write this is that the log of base a, or a to the power of x, is equal to x. And the other way we're going to write this is a to the power of log base a of x is equal to x. Now that we've had a look at these rules, we're just going to look at some examples where we can apply these as well. We're going to start the first one off by looking at a natural logarithm, which is also a name given to a logarithm of base e, i.e. ln x. So our first example will have ln of e to the power 5, which is going to be equal to 5. And this is because ln is our base of e, and as we have a power of e to the 5, as shown above with the rule of log base a, and our a in this case would be our e. Now we're going to look at a second example. So we're going to write 4 cubed plus log base 4 of 7. Now we're going to separate these by using loads of indices. So this will be 4 cubed times 4 to the power of log base 4 of 7. And now here, 4 cubed will be equal to 64, but we're going to times this, and the way to find out what the answer would be, this looks very similar to the rule that we have written above, where we've said that a to the power of log base a of x would be equal to x. So in this case, our x would be 7. So if we do 64 times 7, we'll get 448. Now we've had a look at some examples with numbers. We're now going to add in some variables like x and find what the value of x would be in terms of our logarithms. So for our third example, we are going to have our natural logarithm. So that's going to be a ln of 7 plus 6, which is equal to 19. And now here we've got our variable x inside the natural logarithm. So we're going to get what x is. And so to do this, we're going to raise both sides by the power of e, as ln is, of course, a logarithm of base e. So therefore, we're going to have on the left side, we'll write that e to the power of ln of 7 plus 2x is equal to e to the power of 19. Now here the e and the lengths will cancel out, so we'll get 7 plus 2x, which is equal to e to the power 19. Then we would take away the 7 to put it on the other side, and we'd get 2x is equal to e to the power 19 minus 7, and we'll divide both sides by 2 to get our x being equal to e to the 19 minus 7 over 2. And so this is how we would solve a simple expression which has our variable x. Now for the last example, we're going to look up a more complex problem which involves a logarithm as a hidden quadratic. So let's get started. Log x squared minus 2 log x minus 3, which is equal to 0. So now we want to solve this, and so we'll write this and separate this into two brackets. So we'll factorize the logs out from both sides, as we know it's log squared. So in one bracket we'll have log x, and we'll write log x in the other bracket. And now to get minus 3, we can just times both sides. So we'll have a minus 3 on the right bracket and a plus 1 on the left. And so now we'd get that log x plus 1 is equal to 0, or we can get that log x minus 3 is also equal to 0. Now let's solve the left one. So log x would be equal to minus 1, and we know that log x is log base 10, so we can rewrite this as 10 to the power of minus 1 will be equal to our x, and therefore x will be equal to 1 over 10. Now if we solve the right hand side, log x will be equal to 3, and again because it's a base 10, this will be 10 cubed equal to x, and therefore our x will be equal to 1000. And so now here we've got two solutions to what our x values could be, and this is how you can solve a hidden quadratic kind of question with logarithms. And so now for the next part of the video, we'll be looking at further laws of logarithm, for example, logarithmic addition, and we're just going to be looking at more examples as well. So I hope you liked this video. If you have any questions, do put them down in the comments and let me know what you think. Please do like, subscribe and share, and I will see you in my next video. But for now, Prof Flexin, peace out.